Today we're going to continue talking about our angle measurements and radians. And so we'll start with this reminder that in the coordinate plane, an angle is in the standard position when its vertex is at the origin and one ray of the angle lies on the positive x-axis. So this one right here is on the positive x-axis. That's our initial position right here when it's on the positive x-axis. And then the terminal ray is the second ray of an angle in the standard position. And so that would be this one right here, and our angle would be the one between them. And this is the terminal ray. So here is my initial, and then here is my terminal. Now, when it goes counterclockwise, it is a positive angle. And when it goes clockwise, so this way, it would be a negative. So counterclockwise, positive angle, clockwise, negative angle. It tells us that since we are using the coordinate plane to define angles, we can consider the angles to have a periodic behavior. So we talked about the periodic functions repeating. And so we can say this repeats because as we go around getting angles more and more, then those are going to be periodic. It follows that cycle. Angles in standard position that share a terminal ray differ by an integer number of revolutions. These are called coterminal angles. That means that the initial is right here on the positive x-axis, and the terminal falls in exactly the same place. So, for example, this positive angle has a coterminal that goes this way and hits it. It also has a coterminal that goes around one full revolution and then continues up to here. So we have an infinite number of coterminal angles. The way we measure angles throughout this course and in future courses may seem a bit strange at first. So in geometry, most of these angles you did in degrees. And so we talked about the degrees of a circle. And so we know that a circle has 360 degrees. So this has 360 degrees. Now, in this course and the future ones, we're going to focus mainly on radians. So it tells us that the measure of the angle indicated in the figure on the left is the arc length divided by the radius, radians. So that's the definition of our radians there. It is the arc length, which is this part right here, divided by this radius. That will give us what a radian is. So we've got the definition in words right below that. The radian measure of an angle in standard position is the ratio of the length of the arc of a circle centered at the origin created by the angle to the radius of that same circle. So exactly what we saw here, that's what our definition is right there. Okay, another quick reminder there from your geometry tells you the circumference of a circle is given by c equals 2 pi r. And we can find the arc length by considering a ratio of a circle's circumference as well. Remember, circumference is around this circle. And so we can find the arc length using that ratio. So one last thing from geometry to remind you as well is to convert then. So we just talked about what a radian is. We defined that this radian is a measurement of this part here, just like this angle is a measurement. So radians and degrees can go back and forth from, so they can convert. So we're going to recall from geometry that to convert from a radian to a degree, you multiply times 180 over pi times the radians will give me my degrees, and pi over 180 times my degrees will give me my radian measure. So you can convert back and forth from the degree to the radians. You learned how to do that in geometry, just wanted to make sure that you were reminded of that here. Right, so to continue to introduce you to radians here, we've got this figure. It says, consider the angle theta created by the quarter circle of radius 4 above. Find the measure of theta in radians. And so we've got this quarter circle right here, and we want this measurement. So I'm going to start by finding the arc length. And so I'm going to do the arc length of the hole. And I'm going to divide that by 4 because we just said that was the quarter circle. So that's 1/4 of the circle. So I am dividing by 4. Now for the arc length of the hole, we said that's the circumference. So that would be 2 pi r. So I get 2 pi, my radius is 4, and I'm dividing that by 4 because we want 1/4 of this circle. That happens to cancel out and we get 2 pi. So that's the arc length. Now, to find the theta, we did that on the other side. We do the arc length over the radius. And so I'm going to get 2 pi over 4. And when I reduce that, that becomes pi over 2. So this angle right here is pi over 2 radians. In geometry, you learned that's a 90-degree angle. So 90 degrees and pi over 2 are the same measurement of angles. 90 degrees would be in degrees, pi over 2 would be in radians. All right, so let's try another one here. It says, find the measure of the angle formed by 1/3 of a circle with a radius 3, centered at the origin in the clockwise direction. Okay, so notice that it says in the clockwise direction. So the first thing I'm going to remember is that means it's going to be a negative angle because counterclockwise is a positive angle, clockwise is a negative angle. So we want to find the measure. So we're going to do kind of the same thing we did up there. I'm going to go ahead and make it in one step because I wanted to show you the ways here, but now we can do it here all together. So we get 2 pi over 3. That's going to give me the circumference of the entire circle. This is 1/3 of the circle, so I'm going to divide that by 3, and that's going to give me my arc length. And then I'm going to divide that by the radius so that I can get my theta. Now this cancels right here, and so we get 2 pi over 3. Now, I said I needed that to be negative because we went in the clockwise direction, and so this would be negative 2 pi over 3 for my answer. All right, so radians is important for our next step in learning. We're going to do the unit circle. We're going to start the unit circle, and it is a circle that is centered at the origin with a radius of 1. And so we've gone ahead and labeled the 1 is right there, 1 right there. We know that a radius of 1 means that from that center point to any point on the circle, it is going to be 1 unit. That's why it's called the unit circle. For a unit circle, the radian measure is the same as the length of the arc length formed by the angle. The concept of the unit circle will become pivotal throughout the rest of this course because of its incredible usefulness when working with trigonometric values. So you will have to memorize the unit circle at some point. We're going to start looking at some more angles in our radian mode so that we can get ready for that unit circle. It says, for each of the following, sketch a picture of the arc length described based on a unit circle. Then find the measure of the angle corresponding to the given arc length. So it says 1/6 of a circle in the counterclockwise direction. And so that is going to look like this. And this would be my angle because it is in the counterclockwise. I'll call that theta. And so our theta here is going to be 2 pi over 6. Remember, the radius is 1 for the unit circle. And so we're saying this radius here is 1. And so 2 pi times the radius would be 1. So we get 2 pi over 6. And that reduces to pi over 3. That's going to be one of the crucial angles that we're going to have in the unit circle. While I'm here, I'll just go ahead and remind you. So if this was 1/6 of our full circle in degrees, we said a full circle is 360. And so if you divided that by 6, 1/6 of a rotation, that would be 60 degrees. So pi over 3 is the same thing as 60 degrees. All right, our next one says 2 full revolutions in the clockwise direction. And so we would start from over here, and we're going to go all the way around 2 times and end up right here. And so our theta is equal to 2 times a negative 2 pi. So 2 pi would be all the way around. We're having 2 full revolutions of that. I did it in the negative because we are going in the clockwise direction. So we are talking about negative 4 pi for that angle. All right, for 3/4 of a circle in the clockwise direction, we get theta equals 3/4 times 2 pi. I multiply that and I get 6 pi over 4. We reduce that and we get 3 pi over 2. Now we're breaking up this circle into 3/4, it said, and so here is 1/4, 2/4, and 3/4. So my terminal ray is going to be right here on this angle. My initial is going to be here, so this is my angle. So 3 pi over 2, we know that this is 90, and so this would be 180, and so this would be 270 degrees. So just keep in mind, because I want to give you that reference point for the degrees. Everything we do, we're going to do it in radians, but I want to make sure you have that reference point back from geometry. So our theta here would be 7/8 for 7/8 of a circle times 2 pi. Again, we're multiplying it times 1 as well because the radius is 1. And so we get 14 pi over 8. I reduce that to 7 pi over 4. And 7/8 of a circle would be over here. And so that is my 7 pi over 4. And so it's counterclockwise, so it goes like that. All right. So let's go ahead and look at these radians on the circle, and we can start filling out the radians that you will need to know for the unit circle. It says the circle above has markings at the important angles that will be used repeatedly throughout the course. The radian measures in the first quadrant are given for the circle. Use these angles in symmetry to complete the remaining labeled angles in the circle. So these are the radians that you're going to have to memorize. Just for a quick reference point, I am going to put the degrees. So 0 radians equals 0 degrees. Pi over 6 is the same thing as 30 degrees. Pi over 4 is the same thing as 45 degrees. Pi over 3 is the same thing as 60 degrees. And pi over 2 is 90 degrees. And you learn that in geometry, we're just splitting this circle into pieces. And so we know that this is 180 degrees right here. If we broke it up into 1, 2, 3, 4, the 6 pieces, sorry, so we're breaking it up into the 6 pieces right here, then 180 divided by 6 gives you 30. If we broke it up into the 4 pieces, so 1, 2, 3, and 4, then 180 divided by the 4 gives you the 45. So we're just using fractions here, basically. All right, with that being said, we said this is 180 degrees. That is 1 pi. So this semicircle right here, the half circle is pi. And now we're going to use the symmetry, like it said, to come up with the rest of these. And so we know that this right here was pi over 6. The symmetry for that one is going to be this one. So these are going to match. Now it broke it up into the 6 pieces. 1, 2, 3, 4, 5, and 6. So this would be 1, 2, 3, 4, and 5. So this is going to be my 5 pi over 6. This would be 6 pi over 6, which turns out to be 1 pi. So we are just breaking this up with fractions. All right, so here we have the pi over 4, and so that's going to be this one that has the symmetry. These two are going to be corresponding to each other. We broke that up into 4 parts. So we've got 1 part, 2 parts, 3 parts, and 4. So this is going to be 3 pi over 4, or 3/4 pi. And then these two are the ones that are symmetrical. They are going to be corresponding as well. Here we're saying we're breaking up this pi into 3 pieces. So 1, 2 would be right here, and then 3 pi over 3, which is 1 pi, would be right here. So this one is going to be my 2 pi over 3. All right, as we keep going, you're going to see the symmetry between these two, and these two as well. So those are going to be the same ones. Now this was 5 pi over 6, this was 6 pi over 6, so this is 7 pi over 6. We're breaking it up into our fractional pieces. This was 3 pi over 4, so 4 pi over 4, which would make it 1, and then 5 pi over 4 is going to give me this one. And then for this last one here that's symmetrical to this one, we broke that one up into 3 pieces. And so this was 1, 2, 3. So 3 pi over 3 gives me 1 right there. And so this would be 4 pi over 3. We talked earlier that this was 3 pi over 2 on the one we had up here. So we already know that this one is 3 pi over 2. And then our symmetry goes back to this one right here. So we broke it up into 3s when we got this one. So here we had 4 pi over 3. And so this would be 5 pi over 3. We were breaking this part up into 4s, and we had 5 4s right here. And so here is the 6 and 7. So 7 pi over 4. And then for this one, we have the 6s. And so this would be our 8, 9, 10, 11. So we have our 11 pi over 6 here. All right, so these are all of the angles that need to be memorized for the unit circle. Again, we're going to be using them in radians the entire time. So you have to know where these angles land in the unit circle. You should know the ones that are in the first quadrant, the second quadrant, third quadrant, and fourth quadrant. We went ahead and added the degrees here. I'm going to go ahead and add the other degrees just so that you have a reference point for them. We talked about this was 180. This is 270 degrees. If this was 60, 60 plus 60 would give me this 120. If this middle one was 45, plus 45 gives me 90, plus 45 would give me that 135. This one was 30, and my symmetrical one is right here, so it is going to be 30 away from this one if you want to count that, or you can do 30, 60, 90, 120, 150, so this is 150. My symmetrical parts are right here. So that is going to be 210. And then we've got 225. And I'm going to go ahead and finish these out so that we don't waste time on the video. If you want to go ahead and try it, go ahead and pause and do it. All right, so I've gone ahead and filled out all of the degrees. So go ahead and check those. Again, all of our answers should be given in radians from this point forward, but I did want you to have the degrees there for reference points on the circle just so that you know where they occur. All right. The next part to get us going here for the unit circle, we go back to our sine, cosine, and tangent that we've talked about. It says for a unit circle, the radius is 1. As a result, the sine and cosine values of an angle, theta, in standard position are simplified. So let's talk about what that means. In our previous section, we talked about how sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So this was opposite over hypotenuse and this was adjacent over hypotenuse. Now, when we look at our triangle here that's been inscribed inside our circle, and we have a 90-degree triangle right there, this would be my x value. This is my y value, getting me this point of x comma y. But the radius from the center to the outside of the circle is 1 because we said that our radius was 1 for a unit circle. And so for the opposite of this, that was y, and our radius was 1. And so anything divided by 1 is itself, so we end up getting y. So on the unit circle, the sine value is the y value of that point. For our cosine here, it is the adjacent over the hypotenuse. And so our adjacent is x and our hypotenuse is the radius again. So that would be 1, and that would simplify to x. Now for tangent, that's opposite over adjacent, which in this case is y over x. And so for our tangent, we've got y over x, or we could say it is sine of theta over cosine of theta, since the sine of theta is y and the cosine of theta is x. This is an identity that you'll have to learn later, so we went ahead and introduced it to you there. All right, so let's talk about what that means on this unit circle. So they've given us the point P here on the unit circle, and its x value is 1/2, its y value is the square root of 3 over 2, and it is a radius of 1, as we see right here, so this is the unit circle. It tells us the figure shows a circle centered at the origin with an angle measure of theta in the standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are 1/2 square root of 3 over 2. Find the following values: sine, cosine, and tangent. All right, so let's start with the sine of theta. Up here, we said the sine of theta is our y value. So we know that ordered pairs are x comma y. So my y value would be root 3 over 2. So that is the sine value. That's how easy if we know this unit circle well, this is how easy we can pull the information from it. Our cosine of theta is the x value, and so the x value for this is 1/2. This is going to be the harder of the trigonometric, because we said sine is y, cosine is x. We said tangent was y over x, so I need to do the square root of 3 over 2 divided by 1/2. And so if you remember your fraction rules, that means we're going to keep, so we keep that top one. We're going to multiply times the reciprocal of this one, so that's 2 over 1. My 2's cancel out, and we get square root of 3. All right, for our next one. The point R is the result after point P is reflected over the y-axis. Let alpha be the angle in the standard position whose terminal ray intersects the circle above at point R. Find the following values. And so it tells us that point R is the result after we reflect point B over the y-axis. So that means it's going to be on this side here. We're going to have R. If we reflected it across that y-axis, then our x value became negative. So we get negative 1/2. Now the y values are exactly the same because they're still on this horizontal line here. So this would be the square root of 3 over 2. Now that we have our point, we can easily go ahead and do our sine of alpha, our cosine, and our tangent. So my my y value is the square root of 3 over 2. It is the same as this one since they both had the same exact y values right there. My cosine of alpha is going to be negative 1/2 because that's the x value. And then the tangent is going to be my y over my x, which means that it's the same except for a negative because we're still going to divide this one by this one, which we did right here. But this is positive and this is negative, so we get a negative square root of 3. So this was kind of an intro to the unit circle, so you can start thinking through the different parts. Next lesson, we're going to go ahead and finish up that unit circle.